Hello, welcome back to Philip Wade PLC, and of course I'm Philip. I had a subscriber last week requesting that I make a program showing alternating motor control. So I made it yesterday afternoon, I documented it, tried to make it where it's really as simple as I can. So with that, let's go ahead and get started. I guess the first thing we need to do is look at what my hardware setup is. System configuration. Here you can see I just have a click PLC. This one has DC inputs and relay outputs. And I also have a SIM module that I've plugged into it. And all this does is just give me 8 inputs that I can control with switches, so that I don't actually have to do any wiring for this, for the testing of this program. The model number on the PLC is a C001DR-D. So it has DC inputs and relay outputs. Now the 01 means this one also has the Modbus connection on here. This particular model is, I think at current prices, like $156 from Automation Direct, but you could have gotten the same functionality needed for this application without the Modbus for about $40 cheaper. I think the 00DR-D is right now at about $118. You don't need the SIM module for your real application because you're actually going to have push buttons out there in the field. This shows the PLC that I'm using, the CPU, and this shows my module right here, my SIM module, and it gives me my addresses. It says the addresses that I'll be using on this are X101 through X108. So I'll have 8 inputs here from 101 to 108. And I also have inputs and outputs over here on the click. And you can see there itself, I've got 01 through 08, and then I have Y1 through Y6. Now, one thing I like about this is on the outputs, I don't know if you can see it very well, but this connection here is a C3. I could put DC on this as a supply voltage for this and let this 1 through 4 be my outputs for the lights and run those on 24 volts. But then on the last two, output 5 and 6, I have another common connection here, C4, and I could make this one say 120 volts so that these relay outputs here at 5 and 6 could be 120 volt to pick up the contactors on the motors, for example. All right, let's go back into the program. You can see I've got a lot of things here. It's not really that complicated, but it can be complicated if you've never made one before like this. I want to go to address picker so you can see where my addressing is. On my X's, I'm using my SIM input. So you can see right here, let me get it back up to the top. X101 is my stop button. As should normally, stop buttons are normally closed, so that if a wire gets broken or whatever, you know that there was the same thing as a stop button being pushed. And then X102, I'm telling it to start motor A, that I'm going to simulate a momentary push button. X103, I'm doing the same thing. I'm using that to start motor B. And then X104, I'm using that as my auto selector. Now on this, it's just a simple toggle switch or a 2-position switch. If it's turned on, I add a close signal, it says I'm in auto. If I'm not in auto, then I'm in manual. All right, let's go into the program now. The thing about alternating motor control is it's basically like a flip-flop. That means it's either in one position or the other position. Not anything to do with a flip-flop type of a shoe. Typically, this is like an SR flip-flop, which means set, reset. That means it works as a 0 or a 1. It only has the 2 states that it works at. 0 does one function, and when it's in a 1 state, it does another function. Then it changes again and goes back to a 0. So that's how a flip-flop works. But when you try to do it for the first time using relay logic, you can find yourself running around in circles real easy. Hopefully that the way that I wrote this program will be a little bit more simple to you. So let's go step by step. The first rung that I have is from the auto switch, and it gives me an output to turn on the auto mode light that you might have on the outside of your panel. Let me flip the switch for that one right now. You can see it's energized now, and it turns this on. I'll turn the switch back off. All right, let's go to line number 2. It's saying exactly the opposite of what line number 1 is. If you're not in auto, Then you're in manual. Flip the switch again. I'm in auto. Now I'm back to manual. All right, the third rung is our basics for authorizing the run, making sure that you don't have a stop button pushed, that you don't have any faults such as a motor thermal or whatever else that you might need to wire into this, that your safeties are okay, whatever you have for emergency stop systems. I did not write any program in here for the safety okays or for the fault detected. That's something that you'll write depending on what your application is. But anyway, if I have everything here is okay, I'm going to get this output a light that says run enabled. That means there's no faults and everything is ready to run. If I click the stop button, I press the stop button, I lose my run enabled. Turn it back on, I get my run enabled again because there's no other faults and the safeties are okay. The next thing I have is I have a timer. Now normally this timer is set for 60 and it's done in minutes, but because we don't want to sit here and wait 60 minutes and so many hours afterwards to see this thing change states, I momentarily made it fixed for seconds and 10 seconds as the set point. So every 10 seconds this output T1 will turn on just long enough for one cycle to happen, because when the cycle comes back around to check this rung again, this would be open and it will turn the timer off, which actually resets the value in the timer so it can ready to start back over again. When this turns off, T1, the output, will turn off as well. This goes back to its normally closed state, ready to start counting again if I'm not pressing the button to start motor A or motor B. Now the reason I put these two in here was just to make sure that this went to 0 anytime you told it to start, so that it didn't start off, say, at 50 minutes when it should have started off at 0 minutes. So if I press this button, then watch what happens with TD1 now. I'll just press the start button for number 1. It reset the value, and now it's starting to count back up again. If I do the same thing with motor B, I'll push the button on that. Anyway, let me wait till it gets up to a higher number, say maybe a 5 or a 6. All right, I press the start button for motor B and the timer reset back to 0. So this part right here determines how long the one pump is going to run before it changes over. Now normally, like I said, this is minutes and normally this is set at 60, but just for this program I set it for 10, and also instead of it being minutes, I set this to seconds. That way we can do every 10 seconds would be the same thing as an hour. Now then, my switch hours right now I've got it set at 3. You could set this at anything you want. Say for example, if you wanted the pump to run for 24 hours and then change to the next pump, then you could just set this for 24 hours. You want it to run for 3 days, then change over, make it 72 hours. You want to make it once a week, then you set this for however many hours there are in 7 days. You set this for however many hours that you want the pump to run, and the number is not really limited. You put the maximum number in here, say 999999, and this thing will run for 11 years before it changes over. Every time this reaches the 1 hour point or the 60 minutes point, T1 will turn on for one cycle, and which resets everything back down to 0 on this and starts the count over again. All right, every time that this turns on, saying that an hour has been completed, we're going to get a one cycle pulse right here to the counter, which is going to increase the count value by 1, adding 1 hour to whatever the value is. Now, like I said, I've only got this set for 3 hours right now. Typically, you're going to run 24 hours, one a week or something like this before you change over from one pump to the next or one motor to the next. Most applications just happen to be pumps. All right, for this to work, you must be in auto mode and you need motor A or motor B running, and at the same time you're waiting for this pulse from T1 to come over and close this for one cycle, and on that upswing going from 0 to 1 on this input here, this value will increment by 1. So whatever value it is, it will increment here in CTD3 by 1. Now, when this value in CTD3 equals the value that you have set here for the switch hours, then CT3 will turn on. When that turns on, that starts the flip-flop action. And it comes back and it resets your alternate hours back to 0, so that the next pump motor starts off with 0 hours. So what you see right now is I've got this every 10 seconds. This timer will complete itself, and it will cause an increment to my hour counters over here. If 10 seconds is equal to an hour right now for our application, so that we can see it in this program, and I have this one set at 3 hours, that means every 30 seconds we will be changing from one pump back to the other. All right, rung number 6. You can see that we have the run enabled. That means there's no faults. The stop button is not pushed. The safeties are okay. Manual has been selected because I'm not in automatic. Here is my push button to start motor A, and it tells me that if motor B is running, this push button is not going to do anything. So I have to make sure motor B is not running so I don't run both motors at the same time. And I have the latch right here so that as soon as I tell it that we're running a motor A in manual, it's going to come back and latch this in so that if I let go of the push button, this will still stay engaged. Now it will stay in manual, running in manual, until I hit the stop button, or there's a fault, or a safety stop, something else that would cause me to lose my run enabled. Let's go to the next line. So here I'm still using the run enabled. I'm still using the manual selected, but this time I'm using motor B push button, and I'm checking to make sure that motor A is not running. Both of these rungs are doing exactly the same thing. This one is controlling motor A, and this rung number 7 is controlling motor B. Now let's look at the flip-flop. See, I don't know if I can get up just a little bit. There we go. This rung, these two rungs here, they set which motor starts in the auto cycle. For example, if you want motor A to be the one that starts and runs the first 24 hours or 3 days or whatever, then you would press the start button for that one. If you wanted that to be motor B, you would start that one. And all this does is this just sets up our flip-flop. And our flip-flop is whatever the value is in counter number 5. We're copying a 0 into it to run motor A, and we're copying a 1 into it to run motor B. Remember, I said an SR flip-flop is a set reset flip-flop. So all it cares about is do you have a 0 or do you have a 1. Let's go down to rung number 10. Let me slide this up so you can see it better. And rung number 10, I'm determining whether I have auto enabled or not. To have auto enabled, you already have to have run enabled, and you have to have the switch in the auto position. Then you have to also tell it to start motor A or motor B. And then once you do, then that starts the auto enabled, and that comes back and latches around these push buttons again, so that when you let go of the push button, that auto enable will stay there until either you take it out of auto mode or you lose your run enabled. The next rung is number 11. Slide it up. Now this is the actual counter here. So we're in run enabled, and our alternate hours counter CT3. Right now we have it set at 3 hours. Every time we have the 3 hour complete, then that's going to increment this counter here. So you'll see counter 5 here has a maximum set point of 2. So when it gets to a 2 on the count, then CT5 output will turn on, which comes back and resets it back down to a 0. So that means even though it got to a 2, for one cycle of the PLC, it's going to stay at the 2, then it goes right back to the 0 again. And remember, if this value is at 0, you're running pump A. If this value is at 1, you're running pump B. And if it's at 2, it resets itself back to 0. When that count gets complete, that's going to increment this and cause it to change states. And the state will always change from 0 to 1. And then if it tries to go to a 2, it goes right back to the 0. The next two rungs are 12 and 13. And they're the ones that are selecting which motor is going to run depending on whether this is a 0 or a 1. So here, if counter 5 value is at 1, then I'm going to run motor B. If it's at 0, then I'm going to be running motor A. So far, so good, right? It's not that complicated. If we look at rung 14, the output that we're looking for is to run motor A in automatic. We have to have the run enabled, which, like we said before, is all the safeties are good. There's no stop button being pushed. We have to have auto enabled. We have to have this output right here that we were just talking about from the rung before in rung 13, telling it that we have to switch to motor A. So we would make that one. And we have to not be running motor B. And we're not telling it to switch to motor B. So we're running this one in automatic, motor A, and we latch that back in right here to keep it running until the switch comes to tell it to go to motor B. Now, when it tells it to go to motor B, this value here will open up. It will drop this out, and then we'll make it over here to pick up this one that says run motor B in auto. So you can see both of these rungs are the same, except one of them is controlling motor A and the other one is controlling motor B. The only difference is which one we're going to turn off when we change states and which one we're going to pick up when we change states. Other than that, they're identical. Now then, this is where we actually tell it to pick up the contactor or the relay output to actually start the motor itself. If we have a command to run motor A in manual, or if we have a command to run motor A in automatic, either one is going to pick up this output relay to pick up the motor contactor. Now, you'll see on 17, all we're doing there is we're saying, hey, if we're running motor A, I want a light on my control panel to make sure it shows me that motor A is running. So rung 16 and 17 are just controlling motor A and turning on the light if motor A is running. Now then, 18 and 19 are doing exactly the same thing, but for motor B. So I'm running motor B in manual or in automatic. I'm going to pick up the relay that picks up the motor contactor. And I'm also going to come back, if this relay is picked up, I'm going to come back and turn on the light on the control panel to let you know that motor B is running. Now I've got one more command here, and this one is a call command to a subroutine, and that subroutine is total RT. Let's take a quick look at it. All right, here in the subroutine, I only have 1, 2, 3, 4 rungs of control, and then I have my return to go back to the main program on rung 5. Now, rung 1 and 2 are identical to rung 3 and 4, except for one is pump A and the other is pump B. Anytime that we've got this output relay picked up or the contactor is closed to run motor A, I'm counting the minutes. When I hit 60 minutes, I'm going to pick up T2 output, and that T2 output is going to come in and increment my counter. My counter has a maximum limit set at 99999. That's a lot of hours. That's over 11 years of hours nonstop running. So this will retain that value. You can always see how many hours that pump's been running. And typically you're going to have some type of a display so that you don't have to hook in with a PLC every time if you wanted to see something. You want some type of a display typically on that. And you would use that display, for example, to change your runtime hours. Maybe you've got a SCADA set up and this is linking into through your SCADA system so that you've got a screen that you can look at and say, oh, this pump is set for 24 hours. It needs to be set for 72 hours, so you can change that. These values here in your total runtime hours, you're never going to change those unless you change out the motor itself. Then you want to come back in and reset this count right here. You'll have to have some type of a bit somewhere in your program to be able to say, here I'm just made a bit C100, and if that bit turns on, then this value would reset back down to 0. And something else too is the timer up here, I've got it as retained. If the motor stops and you're at, say, 50 minutes, when you lose this contact here, this bit, and a regular timer, it would cause this value, TD2, to go to 0. You would lose those 50 minutes in the counting of your recording of your motor wear. So this is a retained counter. And a retained counter, when you use it, you must have a reset bit connected to it. So I have this one set up to reset automatically at every 60 minutes. It's going to come back and zero itself, and there's no other way to reset it in my program. The hours, like I said, they're going to increment every hour that you have off of your 60 minutes is going to come in, and it's going to increment your total runtime hours for that motor. And then 3 and 4 are exactly the same, but they're working with pump motor number B. Then we have our return. Go back to the main program. Well, that's it. That's how I would do, very simply using the Click PLC, that's how I would do an alternating pump or an alternating motor control system. Well, let's see how this works. I'm going to turn the auto switch on. So now we're in auto. Let me tell you what. Let me go back and do it in manual first. And I'm going to come down to the manual circuit so that you can see these. Right now I have run enabled. Let me flip the stop, hit the stop button. You can see I'll lose my run enabled. Okay, I'm not in automatic, so therefore manual has been selected. So I'm going to go ahead and tell it to run motor B in manual. So you can see this is running right now in manual. If I try to do motor A right now, it does not change anything. My status stays the same here. I'm running motor B only in manual, and running motor A is not doing anything. Flip it back and forth again, hit the button a couple of times, nothing happens. You can see it changing here as I press the button, but nothing's happening on the output. Now then, if I hit the stop button, it stops the motor. Now let me tell it to run motor A. Motor A is now running, and it will stay running. Let me try to run motor B now at the same time. Motor B will not start. So I press the stop button, and it stops motor A. All right, so that's manual operation. Let's look now at what happens here. If I go to auto, let me turn the auto switch on. You see the auto switch is on now. I'm now in the auto mode. Now then, when I tell it to start a motor, now this timer is just sitting there timing. It's just going from 0 to 10, 0 to 10, 0 to 10. Every 10 seconds it's making a complete loop around. But like I said, this normally is set for 60 minutes and not 10 seconds. But to see it in the program, we don't want to wait for hours to be able to see it change states. Now the timer, this 10-second timer, which is normally 60-minute timer, just for our application, we've got it running every 10 seconds. It makes a complete loop, a complete cycle. So right now it's just running and not doing anything, because whatever the output is on this, it's never getting through to our counter because neither one of the motors is running. Now when I tell it to start one of the motors, say for example I'll start motor A. Now motor A is started. When I press the button, it caused this to reset back to 0. Now then, it's completed 1, and you saw this incremented from 0 to 1. Now, as this time gets up to 10 seconds, again, you'll see this right here changing to a 2, and it changed to a 2. When it reaches the full switch hours, which is now set at 3 hours, then it's going to alternate the pump. And right now you can see that I've changed from motor A to motor B. Let's watch it, what happens over the next 30 seconds. Because the way I have it in the program right now, 3 times of running 10 seconds over here makes 3 hours over here, and I should see a change in my pumps right here. Now, that's 20 seconds. Let's go ahead and wait for another 10 seconds and watch it change from motor from motor B back up to motor A. There, it's changed to motor A. The cycle starts doing the full 3-hour count again over. And for us, that's 30 seconds. That's 15 seconds. $25, $26, $27, and let's watch. It goes back to motor B. And this cycle will continue until I take it out of auto, or I hit a stop button, or if there's some type of a fault or a safety problem that kills the run enable. That's it. That's how simply it works. Let's go down to the bottom down here. We can see we've got auto enabled. This is my motor selector, my flip-flop, so to speak. And let's just watch down here. This is running motor A in auto, and this is running motor B in auto. We'll just sit and watch it for the next 25 seconds or so till it switches again. Now, if you try to do this in straight ladder logic, you can catch yourself walking in circles big time. And it can be really difficult to try and figure out how to do this the first time on your own. I've done this type of programming quite a bit, so it really wasn't that difficult. I just put it together real quick yesterday afternoon. There you go. We just changed to motor B. I just put this together real quickly yesterday afternoon, thought I had it right, and I tried to run it, and I said, oh, I've got a little problem here. I mislabeled this or that. So I made one or two little changes to it, checked it out, made sure it was running properly, and I said, okay, I'm ready to make a video on this. I hope you guys really enjoy these videos. They're not that hard, some of them, to make. This one was a fairly easy one for me to make and produce. Like I said, I just did it for a few minutes yesterday afternoon, and now this afternoon I decided to come in and do the audio part of it. I might spend a total of an hour on this before I get it out, but please like and subscribe. I really appreciate hearing back from you guys. This one came up from a subscriber who asked me to do a program showing how to do alternating motor controls with a click, and this was real easy to do, so I did it. Enjoy it. You guys have fun. Enjoy your program and learn something.